Hey everyone, it's Emily with Spiceworks. Thanks for tuning in today and joining us on another Spiceworks partner webinar. Take a look under the hood of an all-flash vSAN brought to you by Micron. Before we get started, I do want to remind everyone this webinar is being recorded, so if you have to step away for any reason, you will get an email with a link to the video in about a week. Also, there's a Q&A box on your screen to the left. I encourage you to submit your questions at any time during the presentation, and we'll get to those questions at the end via a verbal Q&A. But if your question isn't addressed live, someone will be able to follow up with you. Now I'd like to introduce our presenters, John Nicholson, Technical Marketing for vSAN from VMware, and Jason Massae, VMware Architect from Micron Information Services. So John, whenever you're ready, take it away.
Hi, my name is John Nicholson. As you mentioned, I'm a Technical Marketing Manager at VMware. I focus on Virtual SAN today within the Storage and Availability Business Unit. So let's get started. We've got a lot of content to go over today. So the first thing to talk about, I guess I'll step back and take a high-level view, and let's talk about what all we're virtualizing here. And traditionally with virtualization and with VMware, we've virtualized compute. And you've virtualized memory and CPU, you've consolidated running multiple virtual machines on a host. That was kind of the first step in the journey, as we call it, towards the software-defined data center. The other components that need to be virtualized are networking, which we offer through NSX, and our networking virtualization, virtual switching, and then storage, and that's what we're going to focus in on today, which is with Virtual SAN. And let's talk about what we were really looking to accomplish. What were our goals with Virtual SAN when we started and designed it? We looked out at the market, and we saw a number of problems and challenges that customers were having. One was simplicity. A lot of the storage out there, I used to be a longtime storage administrator myself, we found they weren't very simple. A lot of management of storage, lots of LUNs, pools, different constructs that had to be managed, different layers and nested concepts. Often found ourselves it felt like we were managing by spreadsheet. On performance and scalability, we often find that systems didn't scale cleanly. There often were artificial shelves where you added one more tray of disks or you needed to add a little bit more performance. And suddenly you had to forklift and do a complete rip and replace of your storage infrastructure. And this felt like just a never-ending treadmill, and there was a lot of challenges in terms of not only scaling up, but scaling down for proof of concepts and things like that, and having a system that had a predictable cost and resources associated with doing that. The next one, which I've already hinted at, was cost. A lot of the solutions out there were not very cost-effective. They were generally geared around either performance or capacity. They couldn't necessarily deliver on both. We wanted to make sure we had a solution that could do that and do that in a very controlled way. And the last option was choice. One thing out there with a lot of the storage solutions today, they're based around appliances. You source your hardware from one vendor, and you're, so to speak, at the mercy of their purchasing and procurement and supply chain operations. If you already have relationships with your existing server vendors, you often, when you went to storage, had to establish relationships with other vendors. We wanted to work with all of the server vendors and all the OEMs and all the major ones, even quite a few of the the tier 2 and minor ones. We wanted to make sure that all the ODMs were part of the supply chain, were part of the ecosystem for vSAN, so you could use them. Let's look at the vSAN architecture. So this is a traditional hybrid vSAN I've got here today. And so how vSAN works is it works by replicating local disks, replicating data from local disks between servers. It's a distributed object storage system. And what this means is when you write data, by default that data will be replicated to two different disk groups and two different hosts. In a traditional hybrid vSAN, the solid-state disks acts as both a read and write caching layer. So writes are committed to two different SSDs and then gradually destaged out to capacity drives. We leverage the network for this. At scale, you'll typically want to use 10 gigabit per second Ethernet, but it's something that this design enables you to leverage your existing servers, or when purchasing new servers, be able to purchase servers and just put disks in them. And so from a procurement standpoint, this is a lot simpler. You've got a much more predictable cost. If you're unhappy with your server vendor today, there's plenty of other vendors that are more than happy to establish relationships with you. And we work with all of the different flash vendors out there, and we have certified drives from all of them. So we're able to have an ecosystem for delivering this. And one of the things of why we have kind of a two-tier stage design, and then we have a cache device in front, and we have a capacity device on the back. And the reason why we did that was the cost in terms of capacity when we initially launched vSAN The price per gigabyte for spinning drives was relatively cheap, and the price for solid-state drives for capacity was very expensive. So we wanted to separate out the performance from the capacity. And on the inverse side of that, the cost for performance from flash drives is very inexpensive. Well, the cost for performance in IOP, in and out operation per second here, was very expensive with traditional spinning drives. In fact, if you look today in the market, 15,000 RPM drives, traditionally where we tried to get performance out of our spinning drives, they're no longer really cost competitive even with flash, and even 10,000 RPM drives are really next to go, and we'll get more to that later. So as part of delivering a simple solution, we wanted to make it very easy to enable. So it's baked into ESXi. It's baked into native vSphere. So if you have vSphere 5.5 Update 1 or newer today, you actually already have the vSAN code. It's already running in the kernel. As you see here, it's just another option, just like turning on high availability or DRS. We wanted to have a radically simple solution. I think we say it's 3 checkboxes to deploy. There's obviously an extra licensing key and associated cost, but from a management standpoint, you manage vSAN with your existing vSphere web client. You manage it with your existing tools. And so your VMware admins today do not have to go learn a new storage-specific skill set. They don't have to learn about LUNs. They don't have to learn the unique quirks of a given storage technology. Simply purchase supported hosts with disks in those hosts, enable vSAN, and then you're off to the races. Now, I mentioned earlier we have a hybrid vSAN. We also have all flash, and this is what we're really excited about today. But going over them at a high level today with vSAN 6.1, with hybrid, we've seen up to 40,000 IOPS per host, and then on all flash, we say 90,000. Although in some cases, I've heard some people even getting well above 100. We allow you to choose different classes of flash, so be it traditional SSDs. We allow PCIe, and then the new and exciting NVMe. Because we're a software solution, when the flash vendors like Micron come out with new exciting formats and new capacities of drives, we can recognize and realize those very quickly. In fact, we already support 4 terabyte drives today. So as soon as 8 and 16 of those come out, we'll be certifying those. So there's some exciting stuff. Now, hybrid leverages traditional spinning magnetic drives for the capacity, and all flash leverages a high endurance flash still for a write buffer to absorb the incoming writes, make sure you don't burn out your NAND. But for the back-end drives, it can leverage a much more cost-effective, lower drive write per day, what's known in the industry as a read-intensive device that are much cheaper. In fact, some of the Micron drives I've seen, on street price in the 65 cent a gigabyte range. So you can get some really low, cost-effective flash drives while still keeping it all flash, which is really exciting from a performance and a consistency. And that all flash will give you more consistent latency. I wanted to talk about use cases very quickly. We did a poll of customers recently, and over 60% of our customers are actually putting Tier 1 business-critical applications on vSAN. We are currently at our 3rd version, and version 4 will be coming very shortly. So we're very excited to see adoption, not just of VDI or test dev or staging, which obviously there's great use cases around, very cost-effective. We've seen use cases around DMZs or isolated management clusters where you want to have an air gap or you want to have a separate infrastructure. vSAN scales down, you could have a small little 3 or 4 node cluster for that. For Robo, we do support 2 node clusters for remote office branch offices. So that's really exciting for in cases for grocery stores and manufacturers where they want to have high availability at a branch site, but they don't want to have to use 3 or 4 hosts or invest in a storage array. So those are some kind of, and really from an adoption standpoint, we're seeing it across all industries. So it's exciting to see all the different use cases, and really customers are finding new ones every day. So let me get into a quick deeper dive of kind of what goes on under the covers of vSAN. So we have the first concept, which is called failure to tolerate. And what this means is the number of devices, so that can be either a hard disk or a host that can fail that you can tolerate. The default today is failure to tolerate a 1. And what this means is you can tolerate a drive or a complete host or a RAID controller loss, and the virtual machine will still be available. So, if high availability will still work, vMotion will still work, all the technologies. And that rebuild action can actually happen using the spare capacity of all the other devices. So if you have a device fail on one host, all the other copies of that data that are on other drives will then be able to rebuild to other devices and other hosts. This can also be raised, so you could go failure to tolerate of 2. You could set it so that you could tolerate losing 2 hosts or losing 2 drives simultaneously. You can also raise it to 3, so you can dial this protection. And this isn't a cluster level setting. This is a policy setting that can be defined on an individual virtual machine or virtual disk basis. So you could even set failure to tolerate of 0 if you had an ethereal or a test dev workload that you didn't mind not being able to tolerate failure. So a key message we have here is working with the storage-based policy management is being able to tune your performance, your availability characteristics, and being able to change that on the fly is really cool. It's like being able to change your RAID level without having to move any data around. It'll take care of honoring those policies. So on all flash, one thing we do is when data is committed, it comes in first to the high endurance solid state drive. And hot data will actually basically live in that high endurance, higher perform front end write buffer drive. And the reason for that is these devices oftentimes will have 20 or 30 times the endurance of the back-end capacity drives. So while you may have heard previous stories about flash, having a limited life cycle of writes, these high endurance drives can take up the full size of that drive. So if it's a 600 gigabyte drive, they can take 10 drive writes per day in some cases. So you could write 6 terabytes a day just to that drive. Obviously at a cluster you could write quite a bit. So these drives can take a lot of capacity. And what we do is as the data becomes cold, we age it out to the capacity drives. And so this allows us to leverage, again, high endurance drives strategically while still leveraging the cost effectiveness of lower endurance capacity drives. Now, one thing we do with our caching is, so our data is distributed across the cluster, and we don't try to move that data around artificially to try to keep it close to the VM or do anything like data locality. And the reason for that is the latency on the network is very low. A typical network latency is of actually the new low latency switches can be well below even a microsecond. We can get into the nanoseconds. And the traditional flash devices today have a larger seek time. And what we've discovered is we can deliver very consistent performance by just distributing that data out and not moving it. We've seen some competitors who try to move data around or do things like that. There's a cost associated with moving that data, and technologies like vMotion, DRS start to become a problem and become not supportable, or you lose half your performance whenever a virtual machine moves. We do support using local memory for caches because memory is very effective. From a performance standpoint, the latency is much lower even than of the network. So our technologies, we do work seamlessly with View Accelerator, the content-based read cache for leveraging memory to accelerate VDI workloads. So getting into 6.1, we've got some great new technologies. We've got stretch clustering support. We've extended the vRealize Operations Management Pack to get you some really granular data out of vSAN. If you're replicating with vSphere replication, which is normally a 15-minute recovery point objective, we now can get down to 5 minutes with vSAN. And we've extended a new health and performance monitoring, which gives you proactive monitoring for root cause analysis. If you look back at previous releases in 6.0, we released all flash. We had 64 host limit. We extended performance. Snapshots in 6.0, we moved away from the traditional snapshotting system. So if you've ever heard, the traditional tribal knowledge of don't leave a VMware snap open for 48 or more than 48 hours or 24 hours, with vSAN starting at 6.0, we have a type of redirect write system so that you can leave snapshots open and you're only looking at a couple % performance impact. So that's actually, and you can keep up to 32 snaps open. So if you need checkpoints as part of your workflows, vSAN can actually give you almost a native array-like performance in terms of snapshots. And we also have concept of rack awareness, so you can distribute data across your data center intelligently. So I did want to talk a little bit about the future. We've got an upcoming release, and again, forward-looking statements, typical advice applies here. None of these things are necessarily set in stone, but a lot of these are pretty close. So one thing I wanted to talk about is we have a erasure coding, and it's basically like a RAID 5 over the network we're working on. This is currently in beta, and what this allows you to do is rather than have just normal mirroring, be able to get a much better capacity overhead, so a 1.3x instead of a 2x overhead. A 20 gigabyte disk would only take 27 gigabytes instead of 40. We also have a for failure detection of 2, we're going to be able to support a RAID 6 over the network. Again, similar concept as before. Another technology that there's a lot of excitement around is deduplication and compression. And this is going to be for flash only, as will the erasure coding. And then what these technologies will allow us to do is we'll be able to go very granular with that deduplication and compression. We're looking at a 4K block size. So this means we'll be able to get great data reduction. And on workloads like databases that compress very well or file servers that have lots of duplicates, if you can get a 2 or 3 or a 4x data reduction versus a traditional hybrid, that cost equation for flash being a little bit more expensive than 10K, that starts to compress. And that's what we're really excited about is as flash drive prices come down and we enable flash to be even more efficient with these technologies, it really closes the gap on all flash starting to become the default assumption when designing virtual SAN solutions. We've got some improvements in monitoring, as I mentioned, and so being able to get some cache hits and detail levels, look at individual drive statistics, some really great preliminary things. And one last thing before we go, I wanted to kind of leave this slide out here, which is a great one to muse over. So virtual SAN is, again, not a scale-out file system. It's a scale-out object system. And object systems can do a lot of cool stuff out there. If you're familiar with like Amazon S3, object systems can be exposed through different drivers for things like containers. They can be exposed through REST APIs for systems to write data directly to them. They're very easy to put NAS gateways on. So while today virtual SAN is only exposed as a block VMFS, VMDK like shim layer, we definitely designed it to do a lot more. These systems scale cleanly into the petabytes, and there's really some exciting things we can do down the road in terms of extending data management just beyond enhancing virtual machines. So again, my name is John Nicholson. Thank you for your time, and I'll give the mic over to Jason.
Thanks, John. So my name is Jason Massae. I'm one of the IT architect over at Micron. And one of the things that I wanted to kind of bring is to continue on with what John has mentioned about with the all-flash vSAN. As you've heard with what John had said and what VMware's direction is, a lot of these newer features are going to require flash, and that is because of the overhead that it requires to perform those actions. So dedupe, compression, that type of thing. Under standard drives, it's not really a feasible option. When you look at some of the existing challenges and obstacles of storage in general, there's a couple of key areas. Performance. Generally, you either have a performance problem or you're going to have a performance problem in the future. And the question is, how are you going to deal with that situation? Scalability. What will my existing solution scale? How does it scale? What does it take to scale? Manageability. What does it take to do maintenance? What does it take to do scale? What does it take to do upgrades? All those type of functionality. And then uncertainty a lot of times comes into play with your customers. You know, what is it that your customers, are they predicting accurately? Is there, projects that pop up and somebody says, hey, I need, 100 terabytes and I need a petabyte, where it might be. So when you have your existing solutions, a lot of the standard monolithic solutions, sometimes those are, in order to scale or manage or, change performance, it's not something that's very simple. It's a little bit more arduous in managing that functionality. When we typically look at the history and kind of the growth with storage, we've looked at, there's always been the original SAN, and that's been around for quite a while. And with VDI and some of the extreme spiky workloads and the loads required and the IOPS required for VDI kind of stemmed the AFA, all-flash array revolution. And there's been a lot of vendors that have popped up under this realm, and those are very fast. There's no question about that. And then we go into the next step, which is vSAN. So there's the hybrid vSAN, and then there's all-flash vSAN. Now, I'm not going to go through the details of these. Anybody that would like to go, like I said, we recorded this, but kind of showing this this progression of how we've moved from monolithic, then we've gone all flash, still external storage, and now we've gone into these hyper-converged solutions. And some of the big benefits go back to that previous slide where I said scalability, manageability, and that type of functionality. When you talk about, whoa, what happened here? I jumped. Okay, we're good. Excuse me. When you think about what it takes to manage your infrastructure and look at some of your options, we did for VMworld last year, we did 4 key areas. We did some database solution, we did a mass storage solution, we did a VDI solution, and then we did a robo solution. I'm going to kind of drill into the VDI solution because that kind of stemmed the whole all-flash array. So what we looked at is, in general, VMware has set a guideline that they support 200 desktops per node on a vSAN array. And so when you look at that, what are the requirements? Generally, people say, your minimums are 1 gig per VM. We did 3 gigs. You figure about 30 gigs per VM with a 15 gig adder for linked clones. You're looking at about 12 terabytes. The IOPS, this is kind of funny. Some of the minimum requirements are 25 IOPS. Well, your average laptop drive is capable of at least 60. So if you plan to give your customers 25 IOPS, you're probably going to get a lot of help desk calls. So, but that's, this is the going on paper. So 20K IOPS would be the minimum. 2 CPUs, 8 to 1. We're looking at 200 threads. So an optimal host should have about 25 cores, 600 gigs of RAM, about 3 terabytes of storage. We used some super micros. The reason just being they're very simple, nothing unique about them. They're kind of just a generic box. This kind of gives you the breakdown of the solution. Comes into about $200 per desktop. But what we did is, kind of what's unique is, 3 gigabytes per system, 30 gig hard drive, but we don't have to worry about that 25 IOPS. We're looking at, hundreds, if not thousands of IOPS per desktop. And one of the big benefits of that type of solution is that you no longer have to deal with looking at how am I going to deal with that noisy neighbor? What if I've got somebody that, I've always got this one guy of, maybe he's got a really heavy VM and, he's always doing something that's really intensive and his spike ends up impacting the cluster. So we use a tool called Login VSI to kind of show the capabilities of this VDI all-flash vSAN. And when you run this, what it does is it basically starts powering on VMs and doing just day-to-day operations, browsing web, launching maybe some word processing, Excel, maybe some minor database type stuff. And it just keeps launching desktops until you hit what they call Login VSI Max. Now, when we first ran this, we had a 2,000-seat license, and we were running this on 4 nodes. We actually ran out of licenses before we ran out of performance. So what we had to do is kind of a little trick where we said, okay, we'll continue to use the 4 nodes for the vSAN, but we were going to limit the VMs to 2 nodes. And that way we could artificially limit the VMs to 2 hosts. That way we could figure out exactly how many VMs we could hit that Login VSI Max. When we ran that, we hit Login VSI Max at about 300 VMs per host. So for that cluster, we're looking at 1,200 VMs. That's a huge amount. That's significantly higher than what VMware recommends. Now, we're not saying that you should run that many, but what the big benefit of this type of a solution is that now, let's say you had a 4-node cluster and you need to take 1 node offline. You still have plenty of headroom you're talking about IOPS and latency that you won't even see an impact at all. So now you run it on 3 and you're still running the 800 desktops, no problem. You still have plenty of headroom. And you're not going to have to deal with, oh, well, my users are going to see an impact because I'm taking a node offline for whatever reason. Maybe it's a patch or upgrade or whatever it might be. So that is something that's basically with a hybrid. So this is another significant benefit of the all-flash array, or all-flash vSAN. The other big thing that we were talking about when we go back to that, the obstacles and challenges, is scalability. So even if you were to go look at an all-flash array, one of the things that you have to think about with any external storage device, whether it's all-flash, vSAN, or not vSAN, SAN, or NAS, or anything like that, is that no matter what its performance is, it has a limit. So if I take a system and I put 4 nodes on it, whatever that performance is divided by 4. If I put 10 nodes on it, it's divided by 10. Eventually, I can, regardless of its performance capabilities, even with all-flash, reach a limit. But when you go back to an all-flash vSAN, if I start running out of either capacity or we haven't been able to run out of performance, say you run out of capacity or you start maybe by somehow chance run out of performance, you just add another node and now you've added a whole bunch more capacity and performance. So the scale is linear. And that's kind of the big difference between any external storage device and the hyperconverged vSAN. You scale linearly. So your scalability is, up to 64 nodes is your limit. And then the other options too, within the scalability, is let's say you started off with, maybe 2 disk groups and you only had, 1 terabyte drives. Well, pretty soon the 2 terabyte and the 3.5 terabyte and the 4 terabyte drives are going to come out. You can now just swap those drives out without downtime, and now you've just either, you can double your performance and you can double your capacity, and you don't have to add another node. So there's a lot of different options that you have with the vSAN solution. The other piece that I wanted to show is when a lot of people start thinking about hybrid, they're like, oh, well, hybrid's cheaper. Well, the only way you can get hybrid cheaper is if you use basically the 7,200 RPM drive. That's the only way that it comes in reasonably cheaper. But it's kind of hard to see, but in this graph, when you show our M510 DC here, that green line is the IOPS. So I didn't highlight it in here, but that same line on all of these is just negligible. So we're looking at the 7,200. Again, the only reason you would do that is for pure capacity. You can't get any performance out of that. You could try and get a little more performance. You go up to a 10K, again, maybe a little bit more performance in your IOPS. Again, jump way up into your 15K. Your cost is quite a bit more, but your performance is only negligibly increased. So when you go with all flash, people start thinking, oh, well, it's too expensive. Well, what is it that you're looking for? Because if you're looking at performance, it ends up being less expensive because you don't have to have as many spindles to get your IOPS. You can actually run smaller disk groups if it's IOPS that you only need, because now each drive is capable of 10, 15, 15x what any mechanical drive could possibly do. With that same idea, stepping into when we look at the difference between a hybrid and an all-flash vSAN, on our database testing, what we had done, 2 disk groups, so 4 capacity disk groups, and we used this was a PCIe drive, 700 gig PCIe drive, and what happens is, generally, the hybrid vSAN is capable of very fast performance as long as you're within cache. So if you can guarantee that your performance and all of your workloads are going to be within cache, you will get the same performance. Problem is, that's usually not really a realistic guarantee. So what happens is, as we started pushing the database sizes, and that's what these numbers are on the base here, going past the cache, this start right with that first 500 gigs, that's right past the cache. And that's where you start seeing the degradation in performance. So immediately, once we hit past the cache, the hybrid vSAN immediately starts falling on its face. Because now you actually have to go straight to your spinning media to get your data. So you're back down into the 100 IOPS, maybe 300 IOPS if you've got a 15K or something like that. Whereas when you have an all-flash vSAN, what's odd here is that people say, well, how does then performance increase? Well, what happens is once you've gone past the cache, this is actually just the performance of the system in general. So a single database at 500 gigs, here's its performance. It actually shows that there's actually a lot more reserve available within the performance. And that goes back to what I was showing earlier in the login VSI. You have more headroom available for your systems. So now when you go, oh, well, I may be doing, end of the month or end of the quarter, performance, and I've got to do some financial analysis, I have headroom that is really just sitting there waiting to be used. And I have no problems. Even if I go past cache, I can still maintain that performance that I was intending to purchase. Whereas if I had gone with a hybrid, in order to maintain, just maintain, we're not saying increase, I would have to do 3x the nodes. So again, when we talk about the value, if I'm looking at performance and I want to get that same performance as all flash, 3x is not saving you money. Now you're looking at 3x the cost. Whereas you could have spent a negligible amount more and gotten significantly higher performance. So these are just some of the performance things. This is kind of the big picture that people see, and these are the obvious reasons that you want to go with all flash. There's a lot of other reasons that people don't really think about. When we were doing some testing in this, we took the exact same servers and we put in 10K drives. These were 10K SAS. And then we put in the SSD, which were SATA. And the difference just at idle was about 30 watts per node. Now, it doesn't seem like an enormous amount, but when you're talking hundreds or even thousands of nodes, there's a significant performance increase, or power decrease in using all flash. The other big thing is power decrease is also a heating decrease. So your total heating footprint goes down. So now you don't have to cool as much. So there's a big difference there too. So now you've just added, okay, well, I don't have to run as much power. Now my AC units aren't working as hard because the overall thermal footprint is much smaller. Then the other thing, and a lot of people forget about this piece, is vibration. In a lot of data centers, people don't really think about this, but there's a lot of noise going on in those data centers, and on a 10 or a 15K drive, noise can be, can cause an impact in performance. There's a pretty neat video out there if you search for it. It's a guy yelling at an array. And what he does is he just has a standard external SAN with a bunch of spinning media in there, and he's running dtrace, watching each individual drive. He goes up and he yells at the drive, and the latency goes through the roof. Now, a lot of people don't realize that every time a drive is, somebody slams a door or bumps a drive has to carefully recover itself or protect itself by moving the heads off because it maybe is detecting some vibration. But then the other thing that's nice about an all-flash vSAN is now you can take and put it in some of these more harsh environments. I was talking with Duncan Epping at one point, and he had been working with a customer that had been replacing drives about every 6 months because they were running spinning media in an offshore drilling rig. They've moved to all flash, and now they're no longer having to replace their drives. Talked to another customer one time at VMworld, and he manages NASCAR mobile data centers. He has to bring 2 storage arrays with him because inherently one of them usually fails. And that's because of all the noise and the cars and the movement and everything. So now, again, move into all-flash vSAN, that problem is negated. The other piece that, people are, and John had mentioned this, is that, people are looking at, oh, well, if I use all flash, the cost is quite a bit. Well, what we're looking at now, and I showed that slide previously where it was showing the difference between the cost differences. So like I said, the 7200 RPM drive is the only drive that makes a difference in cost. It's about half, a little more than, it's about a third of the cost. But again, capacity functionality only. You go into a 10 or a 15K SAS, you're at the same price as an all-flash vSAN. So when you start looking at all these other functionalities, vibration, power reduction, cooling reduction, there are other significant benefits that you can get with an all-flash vSAN. The other thing is that these are not these first generations like John had mentioned where people were concerned about, oh, I'm going to burn a drive out. Well, when you build a vSAN, you've got your high endurance drives, and then you've got your read optimized drives. Plus, with the added benefit of how vSAN writes and reads drives, these drives are written in a certain way. Normally, everything is rated against a 4K block. vSAN tends to write at a 1 meg block, which the endurance just goes through the roof. But we're still classifying everything at a 4K block. So because of the vSAN read and write optimization, the endurance is, again, just significantly increased. So when people say, oh, it's going to wear out, it's not. We have not worn a single drive out. And we've been testing this since it was released. So, and VMware has been doing the same thing. So that concern is just, it's an old legacy concern that really does not need to be a worry at all. The other big benefits I mentioned, when you talked about manageability, scalability, very easy to set up, hardware life cycles, those are no longer projects, right? I don't have to do these big, how am I going to manage EOLing my SAN? How am I going to EOL my NAS? Okay, so if I've got an old node in my vSAN, put it in maintenance mode, take it out, put a new one in, put it back in on time. And then with the new stretched cluster functionality, if you have the capabilities, you can do a stretched cluster within, say, a site, say at a larger site, multiple buildings. You could migrate your entire functionality over to one side of another building, take that entire building down, say you had to do power work. Again, these are all things that are very easy to manage, very easy to implement, and you don't need additional software, you don't need additional network connectivity, you don't have to buy additional switching. It's just all your standard network configurations that you would normally do on a virtual environment anyway. So, when you look at all-flash vSAN, or when you look at vSAN in general, you can see when you start thinking about, when I look at all-flash, there really is more value in an all-flash vSAN than there is in a hybrid. So with that, I'm going to wrap it up, and now I guess we'll take some questions.
All right, fantastic, guys. Thanks so much. So we do have a few questions, but if you have a question, continue to get those in, and we'll get those answered while you got the guys on the line. So let's see. Our first question here is from Sam. He asks, does the current vSAN take snapshots on the host or guest level, or can I take a snapshot on the storage level?
This is John. So what we do is we take snapshots at the granularity of a virtual machine, which is good. You don't want to, when you fire off a snap, have to snap 3 virtual machines that you don't really care about. You want to have granularity of different checkpoints. What we do different is, starting in 6.0, we changed the file system. We actually leveraged the file system for that snapshot, a new sparse format. And so while previously, if you took a bunch of snapshots, you would expect performance to dive. Or if you left snapshots open for a while, you would expect to have a really bad time on performance. These new snapshots can be left open safely for days, weeks, and you should only expect single-digit performance hits based on the testing I've seen. So you get the benefits of a traditional hardware offload snapshot without the management headache of granularity problems.
Great, thanks guys. Let's see, Andrew says, sorry if I missed this, but where is your support located?
VMware GSS is located around the world. There's major locations I know offhand in Denver, Cork, Ireland. There's somewhere in Asia for Asia Pac for rolling for what would be night here. I know there's a center, I think in Sacramento. We're all over the place. From a hardware standpoint, if you're buying Micron as part of any of our existing hardware partners through them, everyone from Fujitsu, Hitachi, Dell, HP, EMC, Supermicro, everybody's got support everywhere. So the flexibility of being able to choose, I guess, how you purchase your hardware and your software separately allows you to, I guess, dial in whichever vendor you're most comfortable with from a support perspective.
All right, great. Let's see. Sam asks, how does the licensing work for vSAN, and what is the cost of vSAN?
Okay, so there's a couple different ways to buy vSAN. First of all, I'll ignore this one. There is, if you're a hosting provider, there is special licensing very similar to SPLA for you that you pay per gigabyte, but that's a niche use case. If you're doing VDI, if you're a Horizon Suite customer, vSAN may actually be free for you. So check with your licensing people. In that case, it's actually bundled. We have a per desktop SKU if you're doing VDI, either without View or if you just have the base standard licensing. I think that's about $50 a user list plus support. There's also, if you're just doing it for regular servers, you're not a hosting provider, not VDI, there's the traditional per socket is how the licensing works. You have standard, which is, I believe, $2,500 per socket, and then there's advanced, which is, I think, $4,000. Could be wrong. But again, those are standard prices. There are discounts. There are specials. Please talk to your salespeople.
Great. Is there an option for, kind of a median pricing level where, an SMB could implement this kind of setup?
This is great. So I actually came from a partner and I did some SMB implementations. One thing to keep in mind is since it's per socket, what you can do is go down to a single socket per host, since you can get 10 socket hosts. So if you're doing, say, a 3-host cluster, then you would only need to license 3 sockets of vSAN. So at that point, your list is $7,500 for your vSAN licensing. And so that way you've cut your costs in half basically by going single socket. And what's nice there is you can add sockets as you need more compute and need more things later on. So it's a nice way to scale up.
All right, great. Matt wants to know, are the new dedupe and compression capabilities enabled with hybrid vSAN, or is it all with Flash?
I was going to say, again, that hasn't been released yet, but from what I understand, it's going to be all Flash. And the reason for that is we had to make a decision to either optimize it for hybrid or really optimize it for Flash to go really all out and go well with Flash. And we saw Flash, talking to our friends at the foundries like Micron, Flash was really the way going forward. So in order to get that 4 kilobyte granularity and actually dedupe, and scan all the data, not just parts of the data like some competitors who do it with hybrid, or maybe say they only scan the first 24 gigabytes of a VMDK, we really wanted to do it right and do it well. So in order to make that, we went all Flash or all home, so to speak, in that regard with that technology.
All right, great. Let's see. Don't think we have any more questions at this time. So I guess we'll kind of start wrapping it up. But guys, if you still have questions, get them in, and maybe we can get them answered before we kind of close out. So guys, that was a great presentation. Thank you so much for your time. Do y'all have any final words for our audience?
Yeah, this is John. I would say you can follow me on Twitter, lost_signal. You can generally ask questions there. I know Jason lurks on Twitter also. Check out, from a vSAN perspective, check out the hands-on labs if you want to get your hands dirty with it. It's not on Rails. In VMware's labs for free, we will spin you up a hosted vSAN instance that you can play with. You can try deploying it. You can see how simple the product is and easy to work with. You can also download it for free. And if you're concerned, you've got a large environment, you want to kind of understand sizing and things like that, engage with your vSAN SEs. There's an assessment tool we can run. We'll actually look at your performance in your environment and help you size your nodes accordingly.
Yeah, I'm on Twitter as well. Mine's at JB Massae, M-A-S-S-A-E. And I had just done a couple of posts too, where there's a blog out there that I did that just kind of explains again more of the details of how vSAN really has a better TCO. So you can go out, and if you follow me on Twitter, you'll see that post.
All right, fantastic, guys. It does look like we actually did get a couple more questions in. Do y'all want to get those answered really quickly?
Yeah, let's do it.
All right, Mike wants to know, can we get the link for the test environment?
Yes, I can. And that is, by the way, it's labs.hol, and then hands-on labs.vmware.com. So labs, labs.hol.vmware.com. And you can sign up there for free. And go, and not only just vSAN, there's some other great products, Log Insight, our VDI products. I mean, it's actually pretty comprehensive and awesome.
All right, fantastic. And Matt wants to know what is the recommended cache size for vSAN?
The recommendation is 10% of the actual capacity that will be utilized. That's covered in the design and sizing guides. On all flash, that's really more about just endurance. On the hybrid, that's more of a general, finger in the wind performance guidelines. I've seen people with hybrid size larger. When you size smaller that you could run into problems. So particularly as Jason mentioned, if you had a hybrid and you undersize that to say 4%, your working set was 20%, you're going to have some issues with read cache misses. So that's something where if you're getting into the hybrid and you're really concerned about that, the vSAN assessment tool will actually look at raw SCSI UV traces in your environment and tell you how much of your data is active. So that's a great tool also to help figure out the TCO, which way to go.
All right, fantastic, guys. So it does look like we are completely out of questions now. So thanks so much for that presentation. Hopefully everybody was able to learn a bit more, and that just about wraps it up. So if you had to step out or miss any part of today's presentation, you will be receiving an email in a few days with the link to view the webinar on demand. And special thanks to Micron for creating today's content and sponsoring this great event. And thanks to each and every one of you for tuning in today. We hope to see you back soon for another SpiceWorks Partner Webinar. But until then, stay safe and keep it spicy.